Hey grade 10s. All right, we're back. Let's do this again. So last time we looked at all the types of angles, and today we're going to look at when we have a pair of angles and what their relationship might be. So again, this will be pretty similar to what you did in grade 9, but that's okay. It's part of our curriculum. We're going to go through it. All right, so just want to remind you before we do anything that when we label our angles, we often use these Greek letters alpha and beta. Okay, so those are the Greek letters for A and B. And the reason we do that is because we often use Greek letters in math, and we are seeing an example of that here. Another example of that was when we used theta to represent our angle in our trigonometry unit. So angles we often use to represent, are often represented by Greek letters. So this is another case here. So alpha is the same thing as A, and beta is the same thing as B. Okay, so just in case you didn't know what those meant, that's what they are. All right, let's look at some specific types now. So the first type of pair that we will look at is a linear pair. Those of you who are in class last week will remember me going over this with you, but I am going to do the entire lesson today, so there is some new stuff for those of you who were here last week. When we have a linear pair, they are angles that add up to exactly 180 degrees. Okay, and so because of that, it's actually really easy to figure out if two angles create a linear pair. It's because you can just add them up, and if they equal 180, then they are a linear pair, and if you add them up and they don't equal 180, then they're not a linear pair. So let's look at a couple examples here. So our 37 degrees and 143 degrees, a linear pair of angles. The only way to tell, or I guess the easiest way to tell, is that we're just going to add them up. Okay, so we have 37 and 143. I'm going to add those up in my calculator or on paper, whichever way I prefer. That does equal 180. So yes, they are a linear pair. Okay. Perfect. So the next example. Okay. So 65 and 145, same thing. We're just going to add them up and see if they equal 180. So 65 plus 145 actually equals 210. And so we can say then that 65 plus 145 does not equal 180. Therefore, they are not a linear pair. Okay, so that's how we do those. Let's keep moving. If you have questions about those, of course, just message me in the chat. Okay. The next type of angle pair we're going to look at is vertical angles, and vertical angles are across from each other. That's the key here. In an X-shaped set of lines or more than X. So what I mean by that is an X-shaped set of lines is like here, right? X. So it's two lines that intersect, but we could also have an X with extra lines, okay? And that's all right as well. So as long as all of the lines are intersecting in the middle, like a star or like a snowflake or however you want to think about that, then that's what we're talking about in this case. So the angles will be across from each other in those sets of lines, okay? So in this case, 65 and B are equal to each other. So that means B and 65 are both 65 degrees. And here these two angles, whatever they would be measured, are equal to each other as well. And again, we could rotate this in any direction, okay? So it doesn't have to just be like the top or the sides. It can be in any rotation. Any of the two angles across from each other will be equal. So to just finish off here with this like snowflake shaped one, then this one and the one across from it will be equal to each other. And this one and the one across from it will be equal to each other. Okay, so if that's helpful for you, I would label those in. Okay. So, thankfully, because they're equal to each other, it means that calculating them are very easy, right? So, we know here in the first example, the measures of angles 1 and 4. And because 1 and 3 are across from each other, then we know that angle 1 is equal to angle 3, okay? And if we look at this, we know that angle 2 is equal to angle 4, and so then we know that we can say that as well. Okay, and the reason, again, that we know that is because 1 and 3 are across the X-shaped set of lines from each other, and 2 and 4 are also across. So it's across the middle of the intersection, right? And so because of that, then we can say that since we know already that angle 3 is equal to 126 degrees, I should use the right color. Here we go, angle 3 is equal to 126 degrees. Then we know that angle 1 also has to be equal to 126 degrees, okay, because they are across the X from each other. And similarly, we know that 2 and 4 are across from each other, and we know that angle 2 in particular is 54 degrees, so that means that angle 4 must also be 54 degrees. Okay. So there we go, that's the measure of the missing angles as requested. And the last example on this section is asking us whether it's possible that this angle is equal to 87. So let's take a look at this and figure that out. So if we take a first look, at 87, we know that across the X here, let me make that a little clearer. There we go, will also be 87 degrees, right? So I can write that in. So we know that it's 87 here as well, because, again, they're across the X from each other, right? And so then from there, we know that, let's just take a different color here, that these two angles are going to equal 180 degrees because they're a linear pair, right? So remember, a linear pair is from our first type of angles, we do them here, and we're just saying that here they're going to equal 180 if they're on a flat line together. Okay, so since these two here are on a flat line together, and they also will equal 180. So we're saying that 87 plus the question mark must equal 180 degrees. Okay, so then if we subtract 87 from both sides, we can see that the question mark is actually equal to 93. And so if this has to be 93 degrees, then it would stand to reason that no, it couldn't be true, that the question mark is 87 degrees. So no, no question mark equals 93 degrees, so it can't be 87 degrees. Okay, so that would be our final answer. Okay, so that's kind of how that works. Again, remembering that we're just looking at angles that are across the X from each other to start, and then we can use our previous sets of information as well to figure that out. So in this case, linear pair. Okay, next one is adjacent angles. Adjacent angles are actually really easy because, like I'm saying here in the notes, it's actually more of like a descriptive name than anything else, because it just means that there are angles that share a line, right? So if I'm going to do that in two different colors, so you can see that here there's an angle, right? And then here's another angle, and you can see how they share that middle line, right? And so that is what gives them the term adjacent angles. Adjacent just means like next door in English, and there in math it also does mean the same thing, right? So we can see that these two angles here, this one and this one, they're kind of like next door to each other because they share that middle line. Okay, and then similar reasoning here, like angle 1 is next door to 2, and it's also next door to 5, so 1 and 2 are adjacent, and 1 and 5 are adjacent, like that, and so on. So we are just looking at angles that would be sharing a line to measure the angle together. That's really all that means. The important thing, though, is that adjacent angles meet up with, but never overlap each other, okay? And so meet up with means are connected to, again, by that middle line, like here, okay? But they're not overlapping each other, right? So an overlapping angle, instead of looking like this one, would look like something like, right? And so you can see how there's an angle here and an angle here, and they kind of overlap each other, and that's not what we want. Okay, so that's the only thing worth noting there. All right, next is complementary angles. Complementary angles are nice because they always add up to 90. Okay, so there are two angles that add up to 90 degrees, and so the way that you might want to think about it is you think about that corner that we create with a 90-degree angle, and the two angles that are complementary will kind of be like tucked into that corner. Okay, so that's kind of the device that I use to remember that. But of course, whatever way you want to think about it, okay? So here we can see that we have an angle here. Oops, let's try that again. There we go. And an angle here, okay? And you can see that the 90-degree angle is already indicated there in the corner. And so we know that this first angle and the second angle, when you add them up, they're going to equal 90 degrees. And so that means that these angles are complementary. All right. Now, just a quick notation about, a quick word about notation, a quick note about notation maybe, about these two labels, okay? So when you have something like EDF, what that means is you can find on the diagram E, and then D, and then F, right? And so then whatever line that traces, that's the angle we're looking at, okay? So you might remember that from last year, you might not. We'll mostly use angle names that are just like angle 1, angle 2, but that does happen sometimes where we need to label them with the 3 letters, and so that's how that works, okay? So again, to just go over that, angle CDE, you would find letter C, letter D, letter E, and then find the angle that connects all 3 of those dots or labels, okay? So just a quick note there about that. All right, so let's take a look at this situation and determine the measure of each of those angles. So again, we want to figure out this angle in the first example, and we want to figure out this angle in the second example. Okay, so we can see that we have that angle of 63 here, and so we know that angle EDF, when added to 63, is going to equal 90. And how do I know that? It's because I can see that little 90-degree angle there in the corner. Okay, so that's how I know what we're adding up to. So then just using our algebra skills, like always, I can subtract those 63 degrees from both sides, leaving me with angle, EDF. There we go. Make sure you write that properly. The angle EDF, its measure is left over, right? So you can just do that in your calculator or on paper, like I always say, and either way, that's going to give you a measure of 27 degrees. Okay, so that's the angle of measure of EDF. Then same logic for the next example. Okay, we're going to look at angle CDE. So again, we talked about how that's that angle, and we're going to find its measurement. Again, we can see that little 90-degree box in the corner, so we know that angle CDE plus the other angle of 17 degrees will equal 90. Okay, so when I subtract 17, that's pretty messy. Let's try that again. 17. Oh gosh. Okay, I can just cross those out, and then I'm going to get left with angle CDE is equal to, again, do this in your calculator or do it on paper. I always get questions about this, so I like to go over that. It's going to give us 73 degrees. Okay, so those are our final answers there. Now, I think I took this example here out of your notes, so just don't worry about it. I just forgot to delete it from mine. We're going to keep going to the next page. Okay, supplementary angles. Quick note, actually. If I didn't delete this from your notes, somebody message me, please, okay? And then I will just go over this example again with you in a very quick video. But I'm pretty sure I took it out. Okay, so supplementary angles, we just have a couple examples here down to the bottom of page 8, and then we're done. Okay, so supplementary angles are very, very similar to a linear pair because they add up to 180. Okay, and they often are found in our X-shaped lines, like this example down here, okay? And so I just want to remind you that as long as they are on a flat line, like these two, or like these two, or these two, or these two, then they just have to add up to 180. Okay, so we're just going to look at whatever is on a flat line in any direction, and then we're going to be able to know that they add up to 180. Okay, so in this first example, we're going to look for a measure of angle B. Okay, and so we can see that angle B is right here, and this is what I mean about usually using labels like 1, 2, 3, or ABC. We can just call this whole angle B, and then we don't have to use the 3-letter label. Okay, so we know that angle B plus 71 are going to equal 180 degrees. Now, again, how do I know that? I'm going to take a look here and I'm going to see that straight flat line, right? And I can see that both of the angles here are on that line together, and so that means that together they have to equal 180 degrees. So then, because of that, I can just do my algebra. Subtract 71 from both sides, pardon me, and we're going to get left with angle B, okay, and that is 109 degrees. Okay, so that's how easy that one is. And then if we take a look at the next example, let me just switch colors here, pardon me. Let's use this nice red color. Okay, so in this case, we know that angle B is at 77 degrees, and we know that A and B are supplementary angles. Okay, so those are our two key pieces of information, and we're just looking for the measure of angle A. That's our question mark, okay, that's our X. And so let's do a quick sketch, okay? You can make this look however you like. I'm just drawing like a random diagram to help me visualize what's going on, and we're saying that we want to find out the measure of angle A. Let's make that a little neater. Okay, angle A. And we already know that angle B is 77 degrees. Okay, so again, the reason I can draw these on this straight line like this is because I am told in the question that they're supplementary angles, which means, if you look back in our notes, that they add up to 180 and can be found in any shape on a straight line. Okay, so we're going to go back here and we're just going to do that math then to figure that out. So we know that angle A plus 77, well, even let's go back one more step. Okay, so we know that angle A plus angle B are equal to 180 degrees, right? So that's what we learned right here. And then we also know that angle B is equal to 77. And so because of that, we can replace B with 77. And then that leaves us with algebra abilities to find just angle A. Okay, so that means that angle A is equal to 180 minus 77 degrees, and that leaves us with 103 degrees as our final answer. Okay, so there we go. That's it for our lesson today. Okay, next class I'm going to go on to parallel lines and transversals. There is a practice worksheet that I gave out for you guys already on this information, okay, on complementary, supplementary, linear pair, etc. I really would like you guys to practice those. I am going to, in the next couple days, put up a quiz on our page, or like a hand-in assignment, I guess, and so you will need to know how to do these things in order to complete that assignment. And so I would really recommend that you go through the homework. If you have any questions, you should let me know. I'm available to chat through Teams as always, okay? And if you don't have access to those worksheets for any reason, let me know. I will double check that they all uploaded properly into our Teams page, but they should all be there for you to access. All right, take care of yourselves, ladies. I'll talk to you soon. Bye-bye.